Good morning, America. Are you ready to get big with me for my new workout special edition called the Power Greens and Power Cleans? You want to get your baby spinach and your kale, and we're going to work on these power greens. Notice the all green outfit. So say it with me. You pick it up and you do power cleans, power greens. Now you got your spinach. Do your arm curl with your kale, arm curl with your spinach. Power greens, power cleans. Power greens, power cleans. You want to get big like me. Look at that muscle. Oh yeah, get big. If you like this workout, comment and like the video and let me know how are you getting big during this quarantine. Good morning, y'all. I'm so excited about the continuation of today's lesson on misleading graphs. Today's really interesting. I use a really good TED Talk video as a foundation of the lesson, but then I also give you guys some fun like sports examples and a bunch of different things that will make this lesson interesting. So I hope you enjoy. I'm excited to see second and third period on the Zoom call today, and then fourth period tomorrow and sixth period on Thursday. Cool. Alright, if you want to reach out one-on-one, remember the times are completely opened up. At this point, you don't need to use the Sign Up Genius. You can just go ahead and text me or call me at 770-855-2017 with parent permission, of course. Second and third period, I texted all of you all who I have your number along with your parents about the Zoom call today. If you need the sign-up code, remember there is a password with it, then just reach out and I'll be happy to give it to you again. Alright, so what I want you to do is make sure this is a screenshot from my website. For those of you that just watch my YouTube videos from YouTube and you don't go through the website, I really need you to click pause on this video and watch this TED Talk. It's 4 minutes, maybe 4.5, and is by far one of the best educational TED Talks I've ever seen. And it's going to be the foundation of today's lesson. So go ahead, click pause, go back to my website, watch the video, and then resume where you left off here. Now that you have watched the TED Talk, go ahead and do the bell ringer. Go ahead and click pause in 5, 4, 3, 2, and 1. Welcome back. Here we go. So we have a whole number here. Underneath every whole number, there is a what underneath it. Hopefully you said a 1. So then you just have 7 over 1 multiplied by 4/5. 7 times 4 is 28 over 5. Then you can simplify that. 28 divided by 5, remember fractions or division questions, is 5 3/5. Now let's look at this one. 7 over 1. We have a division question. So do 7 over 1, keep, change, and multiply by the reciprocal, aka flip. You get 56 over 6, and that is 9 times 6 is 54, with 2 6 left over, so that gives you 1/3. And then down here, we have to change this to a improper fraction. So we get 15 17/3 times 9/8. We can simplify this across 9 and 3. 9 divided by 3 is 3. 3 divided by 3 is 1. So then we get 8 times 17 times 4, which I do not know that off times 3. I do not know that, so it is 51. 51/8, which that goes into it 6. 6 times 8 is 48. 49, 50, 51, and 3/8. And then right here, same thing. 5 times 4 is 20, plus 2 is 22. You have 22/5 multiplied by the reciprocal of 5/4. Cross simplify across, you get 1 and 1. You get 22 over 5, which simplifies to 4 2/5. Cool. Find the greatest common factor of 40 and 75. These are your favorites. I know you guys hate GCF. We're going to continue to practice it. When you go to Larson, McKenna, or Myers, you can be really proud that you know how to do this. 40 and 75. So, what breaks up 40? Remember, greatest common factor means divisor. We just do 8 and 5. 5 is prime. 4 and 2. 2 is prime, 2 and 2. Okay, 75. Let's do 25 and 3. 3 is prime, 5 and 5. List out the prime factorization of 40. And you get 2 times 2 times 2 times 5. And then 75 is 3 times 5 times 5. There's only one common factor, so the GCF is 5. LCM of 3 and 75 hundredths, and 1 and 25 hundredths, 1 and 25 hundredths, 2 and 50 hundredths, 3 and 75 hundredths, 3 and 75 hundredths. Don't even need to start. Really, really easy. Okay, now down here, I'm going to switch to blue. Distributive property means to multiply. So x times 4 is 4x. X times 2 is 2x. Uh-oh, you can combine like terms, so you get 6x. Why can I combine like terms? Because they have the same last name. 2 and 25 hundredths multiplied by 5 is 11 and 25 hundredths. Remember, the sign to the left goes with a number, really important for 7th grade. It's minus 2 and 25d. Why can I not combine like terms here? Because this has the d and the other one does not. So then you have 3/4 multiplied by 2g. So you do, I'm going to do 0.75 times 2, which gives me 1.5. So you can do 1 and 1/2 g minus 7.5. And then here we just do 8 times 5, which is 40. And then 8 times 1/2 g would be 4g. And then simplify the expressions below and then evaluate. This is saying 7 times 7 times 7. So simplifying that would be 7 to the power of 3. And evaluate if s is equal to 4. That does not work here. So we're just going to evaluate normally. 7 times 7 times 7 is 343. Here the expression would be expanded, would be 3 times 3 times 3 times 3 times 3. 5 times because of the exponent in the base. And then 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So we have 243. And then s plus s plus s plus s, combine like terms, so it would be 4s, not s to the power 4, and you would get 4, 8, 12, 16. Okay, so now, based off the TED Talk, you saw this right here. It says it shows that Chevy is so much more reliable than Nissan. Like, why would anybody in their right mind buy a Nissan car based off this graph? But if you remember from yesterday, what did I teach you and what did that YouTube video say? You can never start a graph at 95% or not at 0. You always need to have it at 0 in order to show a true representative of data. And of course they did this on purpose though, because they wanted to show, wow, Chevy is so much better than Ford, way better than Toyota, and way, way better than Nissan. However, if you look, it's only like here a half of a percentage point here for Ford, and then even like 1.5 here. And so let's look at what a graph should look like if they would have done it correctly and honestly. Wow. So if you started at 0 and all the way to 100, what do you notice about all 4 of these companies? They basically have the same exact. There is a very minor difference between Chevy and then Nissan. So that is why it's really important to look at the y-axis and see what is this graph trying to show me, and is it a true, honest story based off what I'm trying to figure out. So if you saw in the YouTube video, there's this thing called cherry picking where it shows you I can start my timeline or choose with certain data points to help manipulate me into looking better. So for example, if I wanted to cherry pick for my map data graph, remember when I showed you guys that progression line of the more time you spent using IXL, the more points you will grow. So I didn't, but I could have cherry picked the data of taking maybe the top 30 kids who grew a ton on map, but also spent a lot of time on IXL, and that would have shown a very good progression, a straight, probably a correlation of 0.99, which is a strong positive correlation. It would have looked, the graph would have looked like this, and the line would have gone straight through. So if I cherry picked my data, then I would have been very, very misleading. However, I still showed you there was still a strong correlation of 0.68, which made the line kind of go like this, still in a positive direction. But however, that's how graphs can be used to manipulate your thought processes. So for the example that the YouTube video from the TED Talk gave was how it showed the job growth over time. And it's like, wow, we have so much growth right here of new jobs. Isn't that amazing? However, they cherry-picked their data and they didn't show the graph over time. Where yes, it's still going up from right here, but what happened right here? It was a 2008 recession. Therefore, because they cherry-picked their data, they didn't show the why behind it going up. They should have told the whole story and be like, oh, it went up because we lost 8 million jobs, or 10 million, or however many jobs the Great Recession did. So this is something that you're gonna have to see in this 2020 election, and then the 2024 election as well, and probably the 2022 midterm election. Because what they're going to do is, because right now we're in a massive, massive recession due to the COVID-19. And so a lot of senators, governors, and presidential candidates are going to cherry pick data to show, oh, look all the massive growth we had after the COVID-19. But yes, did the growth go up back to its original point before our recession? Or is it just now starting to go back up because companies are allowed to start operating again? So it's really, really something to think about as you start learning and consuming more news and watching more debates. So this is a fun one from the Super Bowl viewership that was also from the TED Talk video, I believe. Oh no, this is from a website that I found. So it's saying, it was the Super Bowl contested saying that they have a ton of new viewers year after year after year. And it's continuing to go up. It plummeted a little bit in 2005. However, it's gone up a ton. However, in this market from 2005 to 2015, the introduction of smart TVs and access to cheaper TV plans allowed for more people to have access to TV. However, what they did not show you, they did not compare it to, is the percent of people that are actually watching. So that graph is truly not a good representation. So yes, did people go up? Yes, but did the percentage of people who actually watched it go up? That answer is no. So that was really, really interesting to think about. Here, we have two graphs that the TED Talk video talked about, where it showed, oh, there's not a lot of change. This is the average global temperature change. And so it's saying, look, there's not a lot of change at all. If you see, it's 10 degrees Celsius here, 0, and 20. It's not really changing, so why is everybody freaking out about climate change? But however, if you look at the graph here, it's showing you a 1 degree temperature change, where all the scientists and climate change specialists saying is how 1 degree can create a massive, massive ecological and environmental issues. If you look at the polar ice caps that are melting, if you look, sometimes the graph has gone up by over 1 degree Celsius. So it's really important that you focus on the y-axis, because both these graphs are saying the same thing, or are showing the same data. They're both accurate per se, but there's only one that is showing you the true story. So it's however you want to manipulate the numbers in order to tell what story you're trying to share. Now this one is really fun. This is based off of Spotify, so is the U.S. Artist of the Year. And if you look at this first graph on the left, it looks like Drake absolutely murdered everybody. So Drake was at 21 million views, and then I can't remember how to say his name. I'm just gonna call him X. RIP, went only like half of what Drake had. However, but he had 20 million views. So he only had less than 1 mil left. Or less than him? That's weird. And then Kanye had 14 mil. So why is the drop from here to here so little when this gap right here is only 1 million and this gap right here is 6 million? That makes no sense. So we went ahead and I found a more accurate depiction of what this graph should show. And this is a much better graph. So if you look at the x-axis right here, it actually shows us the numbers broken up into smaller increments of 2.5 million. Where before, the increments, there is no x-axis. There's literally nothing to compare it to. So this bar graph has literally no standing on the left side. And this will be the more accurate way to portray the information that we need to know. Now, this is the stock market. So if your parents are really interested at looking at stocks, this is something that Twitter might show people if they want you to invest in their stock. They go, wow, look what we've done from April to May. We've gone up a ton. We've gone from, looks like, right around mid $14 to our peak of right around maybe $19, $19.50. You should buy, and absolutely invest into our company. I was like, okay, if I didn't think about it, yeah, that'd be great. That's 3 months of growth. Yeah, I 100% need to do that. This graph is manipulated. Let's look at the next slide and see what does it look like it's been doing over a 5-year span. So if you look at the max, this is from 2014 to 2017. Right up here, the stock was up to, wow, like $65. And then right now is at $19. So what have you noticed that the graph is showing us? That the stock has actually plummeted, gone straight down over the last 4 years. So if I invested now, maybe it'll go back up. But if I invested back in 2014, I would have lost a ton of money. So it's really important to remember the time frame that's trying to show you and how companies can manipulate even stock prices, graphs. All I'm trying to do is get you to be an effective consumer of mathematical graph knowledge. Now let's look at this one. You know I love college football, and I had to choose this one because this has had my boys, the Georgia Bulldogs, up at the top. So this was for the 2018 season where it said the projected win total. So projected means what you're expected to win. So I had Georgia at 10.9, 10 and 9/10, Alabama at 10 and 8/10, and so on, Auburn at 9 and 1/10. And you can read. However, same thing with that graph from a couple slides ago. There's no x-axis here. A lot of people on Twitter freaked out saying this is a horribly ugly graph because, first of all, why is this 7 and 3/10 the same as this 7 and 3/10, but they're not the same? How does that make sense? Why is this 8 and 4/10 right here bigger than the 9 and 1/10 and bigger than the 10 and 9/10? How does that make sense? Let's look at the next slide for a correct version. This would be a correct version where the x-axis here would be number of projected wins. It allows you to truly visualize and see who has more projected wins and look at them comparatively. So like Alabama and Georgia are right at the top. Then you have Auburn with a close drop-off and so on. So again, do not be fooled by graphs. So I hope when you see things, especially in history, because our textbooks really typically like to, wash the history to define it as it not being as bad as it was. And so it's really important to look at graphs and ask yourself, is this showing me the whole picture, or how are these numbers being manipulated? My goal is to really, really get you to think in life and to say, remember I told you in the beginning of the school year, I want to develop you into compassionate, loving, open-minded, and thought-provoking students. And I really, really hope that these 2 lessons from today and yesterday are really hoping you buy into what we're going to teach when we jump into mean, median, mode, and range, and graphs, and how to create our own graphs because they can tell a really, really good story behind it. Hope y'all enjoyed today's lesson. I'm really, really passionate about this just because it goes into so many different avenues in the world besides just mathematics. Whether you're going into politics, you're going to PR, into marketing, into nutrition, into exercise science, literally whatever career you want, graphs are going to be really, really important. And medical field, and it's important to make sure that you are a strong and intelligent consumer of information. Feel free to share this with your parents as well. I think my mom finds this really, really interesting, and it helps kind of educate everyone. Have a good day. Love y'all. See you guys soon.